Damn it, just as I start the stream, the sun is now in my eyes. Oh, but whatever. This is real GCSE conditions. Some kids might have sun in their eyes if they're sitting in the unfortunate place in the hall, so which is determined by the first letter of your surname. So let's carry on. It's about to go down in a few seconds anyway. So physics, paper 2. So last time I didn't particularly like the paper. I felt it was just ambiguous. But we haven't done any mechanics, really, so I'm hoping there'll be more mechanics in this one, because that's probably my strong point. As far as physics goes. Yeah, so we have this equation sheet as well. And yeah, I mean, I looked at this last time, so. Okay, let's start with this. Okay. Alright, is the sun gonna go down? Right. Time allowed. 1 hour 45, same as before. So this was in June. This was like a whole month after the first one. We need a protractor, really? Okay. Also, I'm using Google for my calculator, so let's just get that ready. All right, and turn this one off. All right, are we ready? Start the timer. Begin. All right. Ah, yes, we got mechanics. Good. All right. Let's see. The student investigated the acceleration of a trolley. So we've got a string, mass holder. Okay. Before attaching the mass holder, the student placed the trolley at the top of the room. What change to the apparatus could be made to prevent the trolley from starting to roll down the runway? Prevent the trolley from starting to roll down? I don't understand. Shorten the length of the runway? No. Move the wooden block to the left, I guess. That will just make the friction overpower the gravitational pull, because it's less gradient, I guess. The student attached the mass holder to the string. The string rubbed along the edge of the bench as the mass holder fell to the floor. Use a pulley. The light gate and the data logger. Increase the resultant force on the trolley and recorded the acceleration of the trolley. Okay. Complete figure 2. Okay. So it goes from 0 to 0.25. So we could do 0.05, 0.1, 0.15, 0.2, 0.25. So we've got 0.08. Okay, 0.18. All right. 0.25. 0.32. 0.41. And now, pretend I used a ruler, okay? Describe the relationship between the resultant force on the trolley and the acceleration of the trolley. Directly proportional plus linear. I mean, that implies linearity, but then I don't know what they're asking for. Describe how the investigation could be improved to reduce the effect of random errors. Reduce the effect of random errors. Well, take repeats for each force value. Reduce the effect of random errors. Just take repeats. I don't know. What else can you do? Okay, what would cause random errors? Friction. Ensure the runway is smooth. No anomalies in... Does this make sense? I don't know. Write down the equation that links acceleration, mass, and resultant force. F equals ma. The resultant force on the trolley was 0.375. The mass was 0.6. Calculate the acceleration of the trolley. A equals F over M equals 0.375 over 0.6 equals... How is this 4 marks? Wait, what? Hang on. Calculate acceleration of the trolley. 4 marks. No. This is not what... hang on. Are we not using the results? Resultant force in newtons. The resultant force on the trolley was 0.375. So this is talking about another file where they use more force than what was in this graph. Okay. Why is it 4 marks? Oh, I don't understand. It should be 2 marks. How can you get 4 marks out of this? It's just f divided by m. Oh, I don't know what I'm missing here. 0.375 divided by 0.6. 0.375 divided by 0.6. 0.35 divided by... Oh my god. I actually do kind of wish I still had a calculator. 0.625. Google is not as easy as they claim to be. 0.625. 0.625. So 0.63. How can that be 4 marks? I don't know. Complete the sentences. Wait, F equals... Yeah, you don't even have to scale up the units or anything. kg is the standard unit there. It's not... Yeah. Complete the sentences. The sun is a stable star. This is because the force is pulling inwards caused by gravity, right? Or in equilibrium, the force is pushing outwards caused by the energy released by nuclear fission. Write down the equation that links distance traveled, speed, and time. S equals Vt, right? Mean distance between the sun and Earth is that. Light travels at that speed. Calculate the time taken for light from the sun to reach the Earth. So S equals 1.5 times 10 to the 11. V equals 3 times 10 to the 8. So T equals S over V. Again, this is, I don't know, sort of easy. 1.5 times 10 to the 11. 3 times 10 to the 8. Put the cross out. That becomes 3. So it's 0.5 times 10 to the 3. Can't even... So 500 seconds. So I know it takes about 8 minutes. Is that right? 8... 500... Yeah, that's about right. Some stars are much more massive than the sun. Describe the life cycle of stars much more massive than the sun, including the formation of new elements. What? 6 marks? I don't know. Oh my god. I don't remember doing this at school. At GCSE level, at least. So more massive than the sun. Why does it matter if they're more massive? Formation of new elements. Stars undergo fusion, combining hydrogen atoms to form helium and release neutrons to produce large quantities of energy. Okay, that might be half right, I don't know. When the star runs out of fuel, the outwards force decreases, causing gravity to dominate, and the star collapses. Then what? It becomes not a black hole. It becomes a neutron star, doesn't it? Or, I don't know. A red dwarf? I don't remember any of this. Star can collapse to form an extremely dense neutron star. If gravity is... Now I'm just trying to remember what happened in Interstellar. If gravity is strong enough, it might form a black hole, maybe, I don't know. The neutron star may transform into a black hole whose gravitational pull is strong enough that light cannot leave the... I don't know any of this. I'm just quoting random phrases and words I remember from Interstellar. Alright. Did I actually answer the question though? They didn't ask about black holes. Life cycle of stars much more massive. And that's enough, I don't know. Stars emit radiation with a range of wavelengths. Which property of a star does the range of wavelengths depend on? Temperature, right? Either that or density? I would say temperature. A ray of light from the ray box should be as narrow as possible. Explain why using a wider ray would give less accurate results than using a narrower ray. Refraction of light at the boundary between air and glass. I don't know. Well, explain why using a wider ray would give less accurate results than using a narrower ray. Oh, it's to do with... Oh, I half remember this. The aperture needs to be, I don't know. I don't actually know the answer to this. Just put something, I don't know. Wider ray would cause reflection, allowing light rays to enter the aperture from different angles than desired. That would be absolute nonsense, I don't know. Estimate the angle of refraction when the angle of incidence is 80 degrees. Show on figure 4 how you obtained your answer. Angle of refraction in degrees. Okay. So let's try and can't. Okay, that's the best I can do. Pretend I'd used. Well, not. You don't want a ruler for this. It looks a bit curved. So I would say around there. So it's 2.5. Describe a method the student could have used to obtain the results in figure 4. I just realized that this is absolutely completely wrong. The point is not to the point is to get it's from the ray box. Hang on. A wider ray would make it harder to measure the angles of incidence and refraction. It would be more difficult to judge where along the width to take the angle reading from. All right, I don't know. The ray box is pointed at the glass a paper surface. A pencil mark can be used to measure the angle of incidence between the ray and the glass, and a protractor a pencil and protractor can be used to mark the required incidence points on the paper where the beam should hit the glass to match the required incidence angles when the ray beam is shown. Is that the word? I can't remember the last time I've ever used that word. Is shown on the glass at such that it meets the mark on the paper. The refracted line a semi-circular glass can be used to ensure no refraction when the ray leaves the glass again. The ray is shown against the flat side of the glass. I think this is how you do it. Will leave the glass at an angle. A pencil can be used to mark where it leaves, and protractor used to measure the refraction angle. Is that what they want? Okay. It's worth some marks, I think. Okay, the student repeated each measurement 3 times. When the angle of incidence is 40, the 3 measured values for the angle of refraction were 28, 25, 22. Estimate the uncertainty in the angle of refraction. Uncertainty? What? I mean, there's many measures of uncertainty. That's a whole field of statistics. They don't, it's not like entropy, is it? No. What could it be? Like what, like variance? I don't remember using something called uncertainty. I remember other things, measures like variance and stuff. Let's have a look at this. Certainty. Should I just do the variance then? So calculators can do this for you, can't they? So what do you do again? You take the mean. So it's bar equals 28 plus 25 plus 22 over 3 equals 28 plus 25 plus 22 over 3. It's 25. Sum of x bar squared equals 3 squared plus 0 squared plus 3 squared. Okay, equals 18. And then, do we want the RMS value or the standard deviation? RMS would make more sense. So just do square root of 18 equals, all right, let's go with RMS. It's not, okay. 4.24. Because that has a strong, easy, that, okay. 4.24. Does that make sense? No. RMS. Root mean square. No, that can't be right. Hang on, I haven't. Equals root of 18 over 3. You have to divide by 3. Divide by n equals root 6. .45. Now that sounds about right. Root mean square. Okay. What property of the light wave changes when it is refracted? The velocity. No. Yes. The velocity. No. Yes. 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 No. Hang. No, it's the velocity which you can determine the angle from the velocity. Well, this is a confusing question because okay, so light changes velocity when it enters different medium, like glass to air, air to glass. So it's true that it changes when it's refracted, but that's not the consequence of refracting. I don't think it changes frequency. I think the reason it appears to change frequency is because you already have light with different frequencies in it, and those different frequencies happen to be going at different speeds, and they end up splitting up. So I think the answer is velocity, but I don't know. If you shone light of a specific velocity, you wouldn't see it change. So a specific frequency, I don't think you'd see it change frequency. Optics. I don't remember optics. Okay, the secret is concave. Figure 5 is the incomplete ray diagram representing a visitor standing near the security lens. Image of the visitor is formed by the concave lens. Concave. So concave is like that. So if a beam comes in like that, or is it this way around? Concave, no, that's convex. So if it comes in like this, it gets focused. I don't know. Image is formed. Okay, so either way, a ray would come from his head. What's F? Okay. I don't think it's, I mean, I thought concave is that shape, but maybe it's not. Maybe it's that shape. And it's like, where is the lens? I don't understand where the lens actually is on this diagram. The door is for the security lens. Lock. So this is the door. So does the lens look like that? What is F? I don't understand. What would happen? No, no, what am I doing? That's too big. It's not going to be something like that. It's going to be... I don't know. Okay, so let's say the light goes towards this here. And it's... So it's not like that. I don't understand this at all. I don't understand. How does the size of the image change? Well, we know what happens. It decreases. Don't know what F is. I don't... Oh, is this line representing the image? So if the beam, light ray beams go like this, so he looks like this, upside down. Is that what? But then what's the other F? I don't understand. The door unlocks when the switch is closed. Which material should the bolt be made from? iron, because it's ferrous. Explain why the door unlocks when the switch is closed. Electromagnetism. I don't remember much of this either. Alright, I just remembered that physics has lots of things like optics and neutron stars and all this stuff that I don't remember. Okay. Where's the mechanics? I know mechanics. Okay, so when the switch is closed... When the switch is closed, the circuit is can't type like this. Wait, and current runs through the solenoid. With current in the solenoid, electromagnetic force acts on the iron bolt. A ferrous... Damn it. The force pushes the bolt to the right. Thus releasing the door from the lock. When the door unlocks, a force of 2.88 newtons is applied to the spring. The spring extends by 1.5 centimeters. Calculate the spring constant of the spring. Let's have a look at this formula booklet. I think this is in here. We've got elastic potential. Oh, elastic potential energy equals 0. Is that what we want? E equals half k e squared. Capital E. So capital E equals half k e squared. Extension. So that is 0.015 meters. What is E? That is energy. Force of 2.88 newtons is applied to the spring. How do you work out the energy? Newtons per meter. Newtons. Oh. I don't think we can. Maybe I'm not using the right formula. Force. Is it? We don't know the current, so we can't use electromagnetism. Mystic potential energy. I have no idea. Where does energy even come from? So wouldn't you need to know the current and everything? No, you would need to know the constant in the first place to get the energy. I'm doing this backwards. Spring constant. So it's newtons divided by meters. Is it? No. Is it actually just divide the force by the... No. Spring constant. Spring constant. Mystic potential energy. I don't think energy comes into this. I don't know where we get the energy from. I don't know. Okay, whatever. The spring constant is n divided by m. Well, that's the dimensions. So should I just divide k equals force over extension equals 2.88 newtons divided by 0.015. Does that make any sense? 2.88 divided by 0.015. 2.88 divided by 0.015. $192. I don't know. Don't understand that. Give two ways the resultant force on the bolt can be increased. Increase current. Resultant force on the bolt. It's current. It's just. Isn't it purely current? Wait, here we are. Force on a conductor. Current times length times magnetic flux density. So use more coils. Higher magnetic flux density. Oh, now we're talking. This stuff I understand. We're running out of time. First two. During the collision, the total momentum of players is conserved. What is meant by momentum is conserved? Sum of momentum of all individual objects is equal before the collision is equal to sum of momentum after. Immediately after the collision, the two players move together to the right. Calculate the velocity of the two players immediately after the collision. They collide and then move off together. So they coalesce. Ah, okay. Okay, so before K1 equals 78 times 7.5 meters per second. 78 times 7.5 equals 78 times 7.5 585. Kilogram meters per second. Kilogram meters. K2 equals 91 times minus 5.5 equals minus 91 times 5.5. 91 times 5.5, 500.5. 500.5 kilograms. Therefore, momentum before equals 84.5 kilograms meters. This one. After mass equals 78 plus 91. 71 equals 167 kilograms. Velocity equals 84.5 divided by 167 equals 84.5 divided by 167. 84.5 divided by 167. 0.506. 0.506. Upon collision, the pads begin to compress as they are made from a spongy substance this applies a deceleration. How do I spell deceleration? One L. To the players for a short period of time until the pads compress fully. The speeds will therefore be reduced, and the change of momentum, change of velocity will be lower in absolute value, which results in less shock and injury. Remote control transmits radio waves to the car aerial. Transmitted radio waves have a frequency of 320 megahertz. Speed of radio waves equals that. Calculate the wavelength of the radio waves. Give the unit. 5 marks? This is not in the... Yeah, because you're supposed to know this. All right, so I think I remember. Okay, so frequency equals 320 times 10 to the 6 hertz. V equals, I think it's this, right? F lambda. Frequency times wavelength. So lambda equals V over F equals 3 times 10 to the 8 over 320 times 10 to the 6. So take out a 10 there, equals 30 over 32. .9375 equals 0.9375. Is that it? 0.9375. I mean, is that all we need to do? Wavelength is literally just meters, isn't it? That seems a lot now that I think about it. Hang on. Frequency 320 megahertz, kilohertz, megahertz, 10 to the 6. Okay. Lambda equals V divided by F, 28 divided by... Well, the speed is high, so that maybe that's correct. Frequency. I mean, the unit is definitely meters. Alright, whatever. Car aerial is connected to an electrical circuit in the car. Describe what happens in the electrical circuit when the car aerial absorbs radio waves. Electrons in the aerial are stimulated and deliver a current down. Is this true? I don't know. I think so. Whose signal frequency matches that of the whose frequency matches that of the signal. Is that what happens? The aerial is a source in the circuit. Similar to a cell. Does this make sense? I don't know. The car produces sound waves. Give 2 ways in which radio waves are different to sound waves. Radio is a form of light. Sound is in the form of particles. 2 ways radio waves are different to sound waves. Radio is latitudinal. Sound is longitudinal. Right, because didn't know. Because sound is like particles hitting particles, so the wave is seen in the direction it's traveling. Whereas radio, it's perpendicular. Right, shows a distance time graph for the first 30 seconds of the car's motion. Describe the motion of the car during the first 30 seconds. One mark, one line. What? Describe the motion of the car during the first 30 seconds. It's like constant acceleration. Is it 2 C's? I don't know. RH. Determine the speed of the car 20 seconds after it started to move. So the speed, we need to draw a little Oh, I don't know. Made a bit of a mess here. $20. All right, so basically we want this line here. So I would say let's bring that line to there and bring it there. So using gradient at t equals 20, delta t equals 5.5, delta ds equals 1.4. So ds by dt equals 1.4 by 5.5 equals 1.4 divided by 5.5. $0.255. Right, a different car accelerated from 0.12 to 0.52. Acceleration of the car was 0.04. The work done to accelerate the car was 0.48. Calculate the resultant force needed to accelerate the car. Huh? All right. We need to know distance. Distance. Do we have any formulae for this? Final velocity minus initial velocity equals 2 times acceleration times distance. V squared minus u squared equals 2as. I think that sounds like the right one. V squared minus u squared equals 2as. V squared minus u squared equals 2as. So we've got 0.52 squared minus 0.12 squared equals 2 times 0.04 times s. So s equals 0.52 squared minus 0.12 squared. 0.52 squared minus 0.12 squared. 0.256. 0.256 over 0.08 divided by 0.08 divided by 0.08 0.08 3.2. All right, sounds nice and round. 3.2 meters. Work done equals force times s equals force times 3.2. S equals 0.48 joules divided by 3.2 meters equals 0.48 divided by 3.2. 0.48 divided by 3.2. 0.15. F. 0.15. That can't be right. Oh, it's a very slow car. So that is a small amount of force. Explain why the car has a maximum speed. Okay. As the car moves, it experiences a drag force in the opposing direction due to air resistance and also from ground. I'm not even sure about the ground friction, whether it applies when the wheels are rolling. This force increases with the velocity. Is it square of the velocity? Increases with the velocity. More than linearly, isn't it? Linearly. I think it's quadratic. As speed... It's actually technically... Well, it doesn't matter. As speed increases, eventually the drag force becomes equal to the driving force, at which point acceleration equals 0. The car has reached terminal velocity That's all you need to say, isn't it? So I say quadratically? I don't even know if it's quadratic. Portable power supply. How do you get 4 marks out of that, though? Which point? We'll find out. Portable power supply, transformer, alternator. Portable power supply has an alternator connected to a transformer. The transformer can be adjusted to have different numbers of turns on the secondary coil. So just why? Let's have a look at our formulas. Formulae. What turns is Vp over Vs. Let's write down the formula. They'll give us a mark for writing. Vp over Vs equals Np over Ns. Vp over Vs equals Np over Ns. Np and Vs are no, this is right. Hang on. Primary, secondary coil, and Vp are fixed by, let's start typing. By changing Ns num coils on sec coil, num turns even, we control the ratio Np to Ns, since Np is fixed. By the above formula, Vp over Vs is equal to this ratio. Since Vp is fixed, Vs would change to keep the ratio matching. This allows us to control the secondary voltage accordingly. Interesting. I completely forgot that's how transformers work. I just learned right now. A lamp is connected to the power supply. The lamp requires an input potential difference of 5. The alternator generates a potential difference of 1.5. Primary coil. Okay. So again, Vp over Vs equals Np over Ns. Primary coil, so that's 150. We need 5. Alternator generates a potential difference of 1.5. We have 1.5. So Ns equals 150 over times 5 over 1.5. Yeah, okay. That is 500. Didn't need a calculator, they could have made it harder. Ah, motors. I remember trying to make a motor in class. I could not get it to work. It's so fiddly. The way you attach the slip ring and all that. The handle of the alternator is turned, causing the coil to rotate. Explain why an alternating current is induced in the coil. Oh God. Okay, are there any relevant formulae here? I'll try and reason this out. Handle. Current. Force on a conductor at right angles to magnetic field. F equals BIL. That's probably what we need. Equals BIL. F equals BIL. So I equals F over BL. It's B. Force. So if we increase... Wait, what? F equals BIL. Force on a conductor, magnetic flux density, current, length. Yeah. These are fixed. Okay, we just have to type. This is not a calculation. By rotating the coil, we are inducing a force in a perpendicular direction to the electromagnetic field created by the north and south magnets. Since I equals F over BL, where B and L are constants, determined by the coil, increasing the force must increase the current, and decreasing would decrease. Okay, so as it rotates, the angle of the force constantly changes continuously changes. So the force the force vector increases to a maximum amount, then decreases to a negative amount. Periodically. The current in turn will alternate in direction along the coil. That's why it's alternating. Suggest the purpose of the slip rings. Reduce friction, which would act against the movement, against the rotational movement, and reduce force. The alternator. Oh wait, no, that's not what the slip ring. Hang on. No, that's what the axle does. Slip ring. No. Slip ring has contacts which allow the circuit to be completed. Even as the coil is rotating. I don't know. Maybe reduces friction is right. Reduces friction, which would reduce force, which would avoid force reduction. The alternator from the portable power supply was disconnected from the transformer and lamp. The alternator from the portable power supply is disconnected from the transformer and lamp. Okay. Explain why the handle of the alternator becomes much easier to turn. Disconnected from the transformer and lamp. The circuit is incomplete. Wait, what? So no current is required by the lamp. Why does... This is to do with energy, isn't it? So no current is induced by turning the handle. This means that no mechanical energy is being converted to electrical energy. And less effort is required to match the same speed of rotations as before. All mechanical input is now being converted to kinetic energy and friction. Heat. That's it. Alright, I don't feel great about this. We've got another 15 minutes. I don't like looking over my questions again, it's so boring, but I should. Use a pulley. This is fine. All right, this one, stars undergo fission, not fusion. Binding hydrogen atoms form helium and releasing neutrons to produce large quantities of energy. When a star runs out of fuel, the outwards force decreases. I don't know. The larger the sun, the higher the gravitational strength. Each of wavelengths. Yeah, I think temperature. That would... Does it? It's not fire, so it's not the same as fire, which temperature makes the flame look different colors. Might be. Okay. I think what I've said is correct, but it's 2 marks. I don't know. This would result in higher variance. I don't know. Uncertainty. Root mean square. Yeah, that's something. Think velocity. It's not frequency. I have no idea what to do for this. What I've drawn here is a mess. Sure, I have an image of the... Draw an arrow to represent the image. What is F? I don't know what F is. Focal points? Incomplete ray diagram. What? Presenting a visitor standing near security. Shall I don't know, draw some more rays here. Okay, wait, why am I not using the F on the right? So what does the concave lens actually do? Does it come back here? Change the... Where does the image appear? Where is our eye? Here? concave. Surely lenses look like that. So if the light goes in, it will be I mean, it kind of turns upside down, doesn't it? No, let's go with my first instinct. Concave should be like that, shouldn't it? So if the beam comes in, let's just go with this. Let's say the concave looks like this. So does this make any sense? All right, whatever. Let's just say he's reduced in size. Okay, I'm gonna remove these because that's not helpful. Iron or steel. Iron's quicker to use. Oh wow, time really flies. We've got 5 minutes left. Increase current, use more coils. Hopefully I'll get the momentum. What was it? Newton's third law? Newton's... I think so. So we probably got that right, hopefully. I don't understand what area, what... I sort of feel confident with these coil stuff now. I'm just working it out from the question itself. slip rings. Okay, should just finish there then. I got to get at least... So I got 80 last time. And you need to average 70. So I got 80 last time, so I can get 60 to compensate. So I just got to avoid losing 40 marks. So actually, I'm still somewhat confident. It's just... there are big chunks that I could lose in one go. I could just easily lose 5 marks in some of those questions, 5 or 6 marks. But I think we're good. All right. Stop the timer. There we go. All right then. Let's put this up again. Okay. There we go. All right, so move the wooden block to the left. Good. Use a pulley. All right, so we're going to complete the graph. Suitable scale, plots pointed correctly, line of best fit. Let's just say I did that right. I mean, that's not easy to grade, but if I had a ruler, it's not, you can't really go wrong, can you? All right, directly proportional plus linear. Yes. Allow f equals ma for 1 mark. F equals ma is not the correct answer to this. What? Why are they allowing that? Right. Describe how it was. Take repeats? Yes. Ignore anomalies and calculate the mean. That comes into repeats. That just kind of goes without saying, doesn't it? Ignore anomalies. I said no anomalies in surface. I don't think that's quite what they meant. All right. Those two things to me just are just one thing. Like obviously if you take repeats, you then have to average them. All right, so we lost 1 mark so far. All right, f equals ma. 0.63. Yep. Gravity and fission. Taste fusion! I always get these confused. Fusion. Damn it. Do not allow weight. Right, so 1 mark. That means I got it wrong in that next question as well. That means it's nothing to do with hydrogen. It's... Oh, but I also confused fusion and fission the other way. So I thought fission was to do with hydrogen. But fusion is, so I probably am still correct there. Right, S equals VT. Yeah. 500. Oh God. Okay, this question. Fusion produced new elements. Out of gas. Oh dear. This is... So I think because I said fission and not fusion, I should lose a mark, right? So a cloud of gas, hydrogen, and or dust or nebula pulled together by gravity, causing increasing temperature to stop the fusing process to become a protostar. Hydrogen nuclei fuse to form helium nuclei, and the star becomes main sequence. Hydrogen begins to run out. Helium nuclei fuse to make heavy elements up to iron. The star expands to become a red supergiant. Star collapses rapidly and explodes, called a supernova, creating elements heavier than iron. And distributing them throughout the universe, leaving behind a neutron star or black hole. Alright, I did not get a lot of that. Let's see. It's not 0. So facts, events, or processes identified and simply stated, but their relevance is not clear. I think that was true. Scientifically relevant facts, events, or processes are identified and their relevance is clear. The account is not fully accurate. I think at least 2 marks. Okay, let's see. I've mentioned neutron star, black hole. I've mentioned gravity, pulling things together. I've mentioned hydrogen forming helium. But there's a lot more you needed to mention. Did I hit level 2? No, I think 2 marks. Because I didn't really describe the actual life cycle. I would say it's either 2 or 3. I mean, when I look at this huge list here, it feels like a 2 because there's so many things. But then again, you don't have to mention all of these to get 4 marks. So, but I've left out some very important things. Okay, hydrogen begins to run out. It could actually be 3. They say the account is not fully accurate. I think most of what I said was accurate. Oh, but I did make a mistake with fusion. So it's not really fully accurate. You know what? I reckon it might be worth 3 marks. Because I did actually hit some of those bullet points. But the other 3 marks, I think you really needed to mention the actual life cycles of the stars. But I did mention the neutron star or black hole. I think 3 marks. So we lose 3. It's there. All right. Temperature. Yep. Harder to judge where the center of a wide array is. Yep. Causing a larger uncertainty. Higher variance. Yeah, that's the same thing as uncertainty. Line of best fit drawn and extrapolated to 80 degrees, 41 degrees. 40 to 43. Yes. Oh, God. Place a glass block on a piece of paper, draw around the glass block, use the Raybox generator. Draw a normal line at 90 degrees to the surface. The one thing I missed was saying draw a normal line. Is that important? Use a Raybox to shine a ray of light at a range of different angles. You increase the angle of incidence 10-degree intervals. I didn't mention the intervals, but then I reckon it's at least 5 marks. But there's a couple of things here. Okay, I didn't mention intervals, but then isn't that kind of obvious? Let's have a look at these levels. The design plan would lead to the production of a valid outcome. All key steps identified and logically sequenced. I think that should really be a 6, to be honest. Drawing a normal line at 90 degrees to the surface, you don't need to do that. It's implied by measuring the Okay, let's see. I didn't mention drawing the normal line. Maybe that's important, maybe it's not, I don't know. Different angles. I didn't mention the intervals. But I don't think you need to mention that. Draw around the class book. All right, there's two things I'm fuzzy on. Should we just say 5? Call it compromise at 5. I reckon it could be a 6, but I reckon there are a couple of points they could catch me out on. So let's go with 5. All right, 2.45. Three? What are they doing here? So they found the mean, which is 25. Which I did. Okay, that's 1 mark. 3 degrees. Where does 3 come from? Oh. So you take the range and divide it by 2? Is that what is meant by uncertainty? Alright, I got 1 mark there. For taking the mean. I did the RMS value, but apparently it's just literally just that half the range. Just say the range then. Okay. Velocity. So, there's a mark there. Alright, this is... I'm not getting these marks. Oh my god. What is this? Image drawn. Okay, the image should be on the left. I had it. No, I didn't have it to begin with. This is a flat 0. 0. Nil point. I do not understand that at all. Alright, decreases. Iron. There's current in the solenoid. Yep. Creating a magnetic field. Attracting the bolt. Oh, damn. I didn't mention magnetic field and I didn't mention magnetized. I think they want those exact words. But I did mention a force of attraction, essentially. So 2 marks here. So I've lost 11 marks so far. I think I'm fine. Right, 192. So it is actually force divided by... Wow, I got lucky there. All right, increase current, use more coils. Increase current, add more turns. Yes. Total momentum before equals total momentum after. Yep. I remember that from Portal. Speedy thing goes in, speedy thing goes out. 0.5, yep. Where did I get... Oh, hang on. Hang on. Why did I have 167? 78 plus 91. Okay. 3. I lost a mark because of my mental arithmetic. 78 plus 91 is 169. So that should be 3. I almost gave myself 4 marks there. Detective pads increase the time taken to stop, so the rate of change of momentum decreases. Reducing the force. Allow impact for force. I did say impact. No, I said shock and injury. I did. Oh, damn it. Hang on. Reduces deceleration. I think I have 2 marks here. I forgot to mention force. Force is the key. Or impact. (0.9375 m). 0.9375 m. Seems like an easy 5 marks there. Alternating current induced in the electrical circuit. Oh, I used induce in a different question, but I forgot to mention induce. Electrons vibrate, oscillate. Stimulated. That's the same thing, right? Vibrate, stimulate. Alternating current. Is the word induce important though? Deliver a current with the same frequency as a radio wave. I'd mentioned that. I reckon that's 2. But why have they underlined these words? Do I absolutely have to? No, okay. They've underlined electrons. So if I've got the word electrons, if the underlining means I have to have those words, I think I'm okay. Right. Sound waves are longitudinal. Okay, yeah, I got that. Radio waves are electromagnetic. Sound waves are mechanical. I said light and particles. Which is true, isn't it? There's speed. Radio is a form of light. It is. Sound is the form of particles. It is. But they don't mention it. It seems like an obvious thing to mention. Wave, particle, duality, all that stuff. I'm going to be harsh and take off 1 mark for that. Because it doesn't seem like they meant that it adheres to what the options they have here, so... Constant acceleration? Accelerating. Speeding up. Yeah. Is it constant? Does it matter? I think I'm fine. And it is constant anyway, I think, because that's like quadratic. Determine the speed of the car 20 seconds after start. 0.255. 0.25 to 0.3. Okay. Okay. Yeah. .15. Yep. Nice. 6 marks. And I got that from the formula booklet as well, so I didn't really remember any of that. Maximum forward force provided by the motor. I didn't mention that. As the speed of the car increases, air resistance increases. Yes. Until air resistance is equal to the size to forward force. Yes. So the car can no longer accelerate. Yes. 3. I didn't mention the bit about maximum forward force, so that's 3. So I lost 15 marks. Not too bad. Oh, there's more questions. Whoops. Okay. Thought that was it. The portable power supply has an alternator. So that you don't need a different generator to vary the output potential difference. To control the secondary voltage accordingly. Okay, I got that mark. They were talking more high level, like what the point is, not how it works. Okay, fine. Good. Coil moves through the magnetic field. Coil cuts magnetic field lines. Oh, I remember that. Okay, I didn't really mention that. There's a complete circuit, so the current is induced. Every half turn, the potential difference reverses direction. I did mention that. So every half turn, the current changes direction. I did mention that. But I didn't really explain the first 2 marks. The first 3 points. Oh, I did say induce. No, inducing a force, but I didn't say inducing a current. Okay, I got the final 2 marks. So the question is, does what I've written hit any of these first 3 points? The coil moves the magnetic field. Potential difference is induced across the coil. I didn't mention that. Complete circuit, so current is induced. I feel like I kind of fuzzily hit that first one and fuzzily hit that third one. So I reckon you could argue that there's 1 mark across. I think you're allowed to mark it like that. I don't know. So I reckon 3 marks, because clearly I've written some stuff which is very weakly hitting. I didn't mention voltage, but I did sort of mention moving through. I mentioned the electromagnetic field created by north and south magnets. So maybe I'm being a bit generous here, but I think 3 marks. Slip ring stops the wires from twisting together. Yeah, that makes more sense than friction. Provides a continuous movable contact. I think I've kind of said that, haven't I? Contact, which allow the circuit to, friction is irrelevant, which allow the circuit to be completed even as the coil is rotating. Isn't that sort of the same thing? movable. That's the same thing as saying it's movable, but not exactly. No, I think what I said is... I think even as the coil is rotating is sort of the same as saying continuous. I think that is fair. The alternator. Why the handle becomes much easier to turn. No induced current. No, yeah, no induced current. Okay. No magnetic field. To oppose the movement of the coil. I didn't mention the magnetic field. Yeah. To oppose the movement of the coil. Yeah, I was talking about energy. What I said might be correct, but it's not quite the point here. I think I'll be harsh here. 1 mark. So I lost 20 marks altogether. Well, that's good. Not too bad. And even if I was a bit generous in places, you could argue I could knock off several more marks and I would still be above 60, which is really the baseline for getting the top grade for this paper. So my total is 160. And as we checked before, that is indeed a grade 9. I think it's 140 needed. Yeah. So there we go then. There's my grade 9. So far we have matched all our predictions. So next time I will tackle electronics. I've gone for a 7. I have a chance now to change it. I think I'll stick with that. I have really no idea what to expect. But I mean, from now on, this is where we get into the subjects that I'm not strong in. Okay then. Well, that was fun to watch. It's funny because I did equally bad in this paper to how I did in paper 1, but I feel happy about this one. No, I feel there was less ambiguity. Paper 1, I felt like I was writing good stuff, but just not meeting what they wanted. Here, I felt I actually lost marks because of my lack of knowledge, and that's reasonable. That's a reasonable way to lose marks. All right. Well, see you next time.